Hi girls, today we're going to go over how to do trig graphs in a bit more detail. So let's have a look at, this is an example, y equals 4 sine 2x. So how do we do that? Well, first of all, we know the amplitude is 4 and we know the period is 2 pi divided by the coefficient of x, which is 2, so that's pi. So now, they're useful things because that's going to help us tell us the shape of the graph. Also, I want you to notice something. If I draw a graph, so here's my x-axis, and there's my y-axis. Now, I want to show you something. First of all, normal sine x goes up by pi on 2, then pi, then 3 pi on 2, then 2 pi. Okay? Try to make your values evenly spaced. Then negative pi on 2, pi, negative 3 pi on 2, and negative 2 pi. Alright, so usually normal sine x, so I'm just showing you normal y equals sine x because we're going to refer to this. Sine x. Now, the amplitude of normal sine x is 1, so we go to 1 and negative 1. And how do we draw it? Basically, sine of 0 is 0. Now, I just want to remind you, before I keep going, with the unit circle, and these points are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Remember, sine is the y value, so you're concerned with 0, 1, 0, and negative 1. And also the angles here would be 0. The angle here is pi on 2 going around the unit circle from the x-axis. It's pi. And this is 3 pi on 2. And then this is back to 2 pi. So I want you to keep referring to that unit circle to work out the values, okay? So, sine of 0 is 0. Sine of pi on 2, that's pi on 2 up here. The y value is 1. Sine of pi is 0. Sine of 3 pi on 2 is negative 1. And sine of 2 pi is 0 again. So my graph looks something like this. Because you have a grid book, hopefully yours will look even better. Now, it keeps going on this other side, so we're going in a downwards motion, so it's going to be at negative 1 here, 0, 1, and 0. So that's normal sine x. We're going to refer to that. So now back to our current equation, which is y equals 4 sine 2x. How do I do that? Girls, we divided the period by 2. Because everything's going to get squished inwards by 2. It's kind of like it's going to be halved. Now, what we do is, I want to know what the first important x value is of my new function. Usually, for sine x, it's pi on 2. But for my new function, I need to once again divide that by 2, because 2 is the coefficient of x. So we shift everything, we halve everything in the horizontal way. So we get pi on 2 divided by 2, which is pi on 4. It's also like timesing by a half. So what that tells me is, for this function, my first important point is going to be pi on 4, but also that I'm going up by pi on 4, because, girls, back here for y equals sine x, we're going up each time by pi on 2. So that's what's significant about this value here. Pi on 2 is not only the first important point where we're up here, but we also go up by pi on 2. So for this new one, pi on 4 is our first important point, and we're going to go up by pi on 4. So I'm going to draw a new axis. So now, girls, I'm going to go up by pi on 4. So that's pi on 4. pi on 4 plus pi on 4 is 2 pi on 4, or in other words, pi on 2. The next one will be 3 pi on 4. The next one is 4 pi on 4, or in other words, pi. And I might just stop there for now. On the other side, I have negative pi on 4, negative pi on 2, negative 3 pi on 4, and negative pi. So it's the same but negative. All right, so now let's start drawing. So at 0, when x is 0, let's go look back at our function. I'm going to write it over here now. Okay, we'll work from the inside out, girls. If x is 0, 2 times 0 is 0. Sine of 0 is just 0, because look back here at our unit circle. When x is 0, the y value is 0. So sine is 0, and then 4 times 0 is still just 0. I'm at 0. Okay, let's keep going. Pi on 4 is my next x value. So what's 2 times pi on 4? That's pi on 2. Sine of pi on 2, looking back at your unit circle, girls, that's 1, sine of pi on 2. 4 times 1 is 4. Now I just realized I haven't even put 4 on the y-axis. So my amplitude is 4, so I go up to 4 and down to negative 4. So for pi on 4, I'm at 4. Now next one, pi on 2. 2 times pi on 2 is pi. Sine of pi is 0. 4 times 0 is 0 again. I think you might see a pattern. Next, 3 pi on 4. 2 times 3 pi on 4 is 6 pi on 4, or in other words, 3 pi on 2. Sine of 3 pi on 2 is negative 1. 4 times negative 1 is negative 4. And I think you can guess what's going to happen with the next one. When x is pi, 2 times pi is 2 pi. Sine of 2 pi is 0. 4 times 0 is 0. So I get this kind of shape here. And I'm going to do that on the other side, but flipped. So negative pi on 4, it's actually down here. Then we're back here. Then we're there. Then we're there. Because we're going downwards direction. Then we go up and then down. So that there is y equals 4 sine 2x. Okay. Y equals sine of 3x minus 2. Okay. So what can you tell me? The amplitude, well, there's an invisible 1 here, so the amplitude is just 1. The period is 2 pi on 3, the x, the coefficient of x. So what's my important point? Sine x, first important point is x equals pi on 2. So I get pi on 2, and I divide it by, once again, it'll be divided by 3, which is pi on 6. So once again, I'm going up by pi on 6. Actually, girls, let's have, for some fun, let's make this negative sine 3x minus 2. Okay, so that doesn't change the amplitude. The amplitude is not negative 1, it's still just 1, because amplitude is a length. So it's a positive. Okay, so we have our important point and what we're going up by along the x-axis, but we have to shift it down 2 using that negative 2. So let's have a go. But I'm going to go up to maybe 2 and see how that works. But hopefully you're going to realize if sine x has an amplitude of 1, it goes from 1 to negative 1. But if I then shift that down 2, I actually need to go all the way down to negative 3. But you'll see that in a minute if you're not sure. And once again, I need to go up by pi on 6. So we got 2 pi on 6, which is pi on 3. 3 pi on 6, which is pi on 2. 4 pi on 6, which is 2 pi on 3. 5 pi on 6, which is just 5 pi on 6. And I better extend it. 6 pi on 6, which is just pi. And so same thing over here. So when x is 0, what do I get? 3 times 0 is 0. Sine of 0 is 0. So I get negative 0, which is just 0. And then 0 minus 2 is negative 2. So I'm there. Next, when x is pi on 6, I might do this showing you the working. When x is pi on 6, I get y equals negative sine of what's 3 times pi on 6 minus 2. So I get negative sine of, this becomes pi on 2 minus 2. Sine of pi on 2 is 1, so I get negative 1 minus 2. Oh, look at that, negative 3. I'm going all the way down to negative 3 when x is pi on 6. Oh, sorry, what have I done here? That should be pi on 3. Sorry. Okay, now if you do the same with pi on 3, you get, in here, you get pi on 3. 3 times pi on 3, that's actually just pi, sine of pi. Now, sine of pi is 0, and negative 0 minus 2 is negative 2. So here, we're actually at negative 2. We see we're already done this shape. So I wonder if you know what will happen for pi on 2. I'll show you the working. When x is pi on 2, we get y equals negative sine of 3 times pi on 2, which is 3 pi on 2, minus 2, which is sine of 3 pi on 2, using your unit circle, that's negative 1. So I get negative 1 minus 2. That becomes 1 minus 2, which is negative 1. So I'm actually here. Look at that. I'm turning around already. Hopefully now you can see that my curve is just going to go back down to here, and then back up to here. You just follow the pattern just like the normal sine curve. So that's what the looks like. What's going to happen on this side? I'm going up, so I must be going up to negative 1, then down, back down to negative 2, down to negative 3, back up to there, back down. So you just follow the pattern. Even though we're not just going around the x-axis, you just follow the pattern like that. So that is your final answer. So here is when it becomes interesting. We've got sine of, so let's do 4 sine of x plus pi on 4. All right, so here, what does this thing do in here? This shifts us to the left pi on 4 units. So what I want to do first, to make it a bit easier for me, I'm going to first draw the simplified version, which, well, not simplified. I'm going to forget the pi on 4 for a minute and just draw this. Then I'm going to use this shift to pi on 4 units. That's what I'm going to do. That's how I'm going to approach this. And you know we're shifting to the left because it's positive inside where the x is, so therefore you'd go in the opposite direction. So first of all, what is my amplitude and period? My amplitude is 4. And my period, girls, the good news is, the period is just, 2 pi on 1, which is 2 pi, because the coefficient of x is just invisible 1. So it's just the period still like usual. So I do know I can put 4 and negative 4 on my y-axis. And I'm going to go up by my usual x values that sine x usually goes up by, which is pi on 2. Because I didn't really divide it by anything. It divided by 1, which is just not changing anything. So I go up by pi on 2. So let's go this time all the way up to 2 pi, because we can. It's easy. So I'm just going up by pi on 2. All right, so at the moment, I'm just focusing on y equals 4 sine x. So that's just, looks like just the usual sine curve, but we're going up and down to 4. So at pi on 2, we're at 4. And you can check these by working them out on your calculator, but these are the values. So what I should do actually is draw this in more lighter color. So I'm going to draw this in a light, like a pencil. Because this isn't my final answer. So I don't want the marker to think this is my final answer. So what I might do is I might even label it as 4 sine x. Even, you don't technically have to even rub it out. You could just leave it like that and pencil much lighter than your final answer so that the marker knows, oh, this is just what you did to get there. Okay, so now I'm going to draw my actual one. Now what's happening? we are shifting to the left by pi on 4. What's pi on 4? Pi on 4 is actually half of pi on 2. It's halfway between 0 and pi on 2. So I want to go back half the distance between my main points that I've drawn. So for instance, this point here, I want it to bounce backwards halfway. This point here, I want to bounce backwards halfway. Do you see what's happening? I'm bouncing back pi on 4, which is just halfway. So this point moves there, this point moves about there, this point moves about there. Now, you don't have to draw this movement like I'm doing. I'm just trying to show you. So, this point moves there, this point moves there, this point moves there. So it's halfway, okay? So now my final graph, so I might actually rub out what I didn't want you to draw. We'll draw our final graph, which is this one, which we'll do in darker pen, and we're going to label it to make sure the marker understands that this is actually our answer. Mark this one. So this here is y equals 4 sine of x plus pi on 4.